50 million years ago, Earth was a planet unlike anything we'd recognize today. Imagine a vast supercontinent stretching across the globe, surrounded by a single, endless ocean. Deserts dominated the land. Volcanic eruptions filled the skies with ash, and strange, sail-backed reptiles ruled the arid terrain. Beneath the waves, bizarre marine creatures thrived in seas, teetering on the edge of collapse. This was the Permian period, a world of brutal extremes and constant adaptation, but it would all come crashing down in a catastrophe so severe it wiped out 90% of all life on Earth. Welcome to Armchair Archaeology, where we explore the untold stories of Earth's ancient past. In this episode, we'll take you on a journey through the Permian period to uncover the creatures, climates, and cataclysms that define this era. Along the way, we'll see how the events of the Permian hold haunting parallels to modern environmental challenges, from greenhouse gas emissions to mass extinctions. And stay tuned, because at the end of this video, we'll reveal just how destructive the volcanic eruptions at the end of the Permian truly were. Hint, they burned through trillions of tons of coal, unleashing a chain reaction that changed the planet forever. You won't want to miss it. Before we dive into the incredible story of the Permian period, don't forget to subscribe to Armchair Archaeology. By subscribing, you'll join a community of curious minds uncovering the secrets of our ancient world twice a week. Hit that bell icon so you never miss an episode. Over 300 million years ago, Earth entered the Permian period, a time of remarkable transformation and challenge. During this era, the planet's land masses were fused into a single, enormous supercontinent called Pangea, stretching across the equator and spanning thousands of miles from pole to pole. Surrounding it was the immense Panthalassa, the world's only ocean. Pangea's sheer size created extreme environments, with much of its interior far from the moisture of the oceans. Vast deserts dominated the land, with temperatures swinging wildly between scorching days and freezing nights. Life clung to the more stable coastal regions and seasonal river valleys, where conditions were easier to endure. But despite these challenges, life thrived in surprising ways. Early seed-bearing plants, or gymnosperms, adapted to the arid conditions, with tough seeds that allowed them to survive where older plant species could not. To put this in perspective, older plants like ferns relied on spores that needed water to reproduce, while gymnosperms' seeds acted like tiny survival capsules, thriving even in dry environments. This adaptation was a game-changer for life on land. Forests of ancient conifers and cycads began to take root, forming scattered green islands in Pangea's otherwise barren interior. Meanwhile, rivers and wetlands became vital refuges for amphibians and early reptiles, which were evolving new traits to conquer life on land. And the land itself was constantly shifting. The tectonic collisions that formed Pangea created towering mountain ranges like the Urals, which reshaped wind patterns and rainfall. These mountains trapped moisture on one side, creating fertile zones, while leaving vast deserts on the other. This dynamic interaction between geology and climate created a patchwork of environments where life either adapted or perished. The Permian world was one of extremes, but it was also a proving ground for life, where the adaptations of plants and animals set the stage for the extraordinary events to come. If you're fascinated by stories of ancient worlds and the mysteries they hold, check out our ebook, Secrets of the Ancient World. It's packed with discoveries about lost civilizations, advanced technologies, and the unsolved puzzles of history. The link is in the pinned comment. The climate of the Permian period was as extreme and unforgiving as the landscape itself. With nearly all of Earth's landmass joined together in the supercontinent Pangea, weather patterns were dominated by its sheer size. Much of Pangea's interior lay far from the ocean, resulting in vast, dry deserts where rain rarely fell. Here, scorching heat baked the land during the day, only to give way to freezing temperatures at night. A relentless cycle that pushed life to its absolute limits. But the edges of Pangea told a different story. Along the coasts and in low-lying river valleys, seasonal monsoons brought torrential rains, transforming these regions into fertile oases. These areas became vital lifelines, supporting dense forests of gymnosperms and dynamic ecosystems where predators and prey thrived. These fertile zones were critical in the evolutionary race, giving early reptiles and amphibians a place to evolve and compete. The Permian climate was also marked by monumental change. As the planet transitioned from an ice age into a warmer, more volatile phase, global temperatures began to rise sharply. Scientists estimate that during the Middle Permian, average temperatures reached 25 degrees, 77 degrees, significantly higher than today's average of 15 degrees, 59 degrees. At the same time, oxygen levels dropped, creating an atmosphere where survival became even more challenging. This warming wasn't just a natural progression, it was a prelude to catastrophe. As we'll see, the changing climate combined with the geological upheavals of the late Permian to create conditions that would devastate life on Earth. Yet, these very extremes also forced plants and animals to innovate, adapting to an unpredictable and often hostile world. The Permian period wasn't just an age of extremes, it was also a time of remarkable evolution. In the arid deserts and lush river valleys of Pangea, life was finding ways to adapt and thrive. One of the most significant breakthroughs came from the gymnosperms, the first seed-bearing plants. Unlike their spore-producing ancestors, gymnosperms evolved tough seeds that could survive in dry environments. Ancient conifers, cycads, and ginkgos spread across the supercontinent, creating scattered forests that provided vital habitats for animals struggling to endure the harsh climate. At the same time, insects were dominating the land and skies. Giant cockroaches roamed the forest floor, while enormous dragonfly-like predators with wingspans of up to 70 centimeters patrolled the skies. These creatures thrived thanks to higher oxygen levels in the atmosphere, which allowed them to grow far larger than insects today. However, as oxygen levels began to decline in the late Permian, the reign of these giant insects came to an end. Early vertebrates were also undergoing revolutionary changes. Amphibians, which had long depended on water for survival, began evolving tougher skin and stronger limbs, allowing them to move farther inland. But it was the reptiles that gained a critical edge with their amniotic eggs, which had protective shells that allowed them to reproduce away from water. This advantage opened up new territories deep within Pangea's interior, paving the way for the rise of land-dwelling predators. Imagine stepping into the scorching deserts of Pangea, where survival meant constant competition. Here, apex predators reigned supreme, with Dimetrodon standing out as a sail-backed synapsid and distant ancestor of mammals. Dimetrodon's sail wasn't just a striking feature. It may have helped regulate its body temperature, allowing it to hunt effectively in Pangea's sweltering deserts. Picture this: a Dimetrodon basking in the early morning sun, its sails soaking up heat like a solar panel, gearing up for a day of hunting. In an environment where temperature was everything, this adaptation was key to survival. The Permian period wasn't merely a time of survival, it was a proving ground for new strategies and adaptations that would shape life for millions of years to come. What's the most fascinating thing you've learned so far? Let us know in the comments. We'd love to hear your thoughts and theories. In the harsh landscapes of the Permian period, apex predators ruled the food chain, and one of the most iconic among them was Dimetrodon. Often mistaken for a dinosaur, Dimetrodon belonged to a group called synapsids, distant ancestors of mammals. Measuring up to 5 meters in length, this sail-backed predator was perfectly adapted to its environment. Its powerful jaws, lined with serrated teeth, made it an efficient hunter, capable of taking down a variety of prey, including amphibians and smaller reptiles. Dimetrodon's most striking feature was its sail, formed by elongated spines on its back. Scientists believe the sail served as a thermoregulatory tool, allowing Dimetrodon to absorb heat in the cool mornings and release it during the scorching afternoons. This ability to regulate body temperature gave it a significant edge in Pangea's extreme climate, where survival often depended on adapting to sudden shifts in temperature. But Dimetrodon wasn't alone in the Permian's predator lineup. Other synapsids, such as Sphenacodon, prowled the land, using similar hunting strategies. Meanwhile, the forests and wetlands were home to massive amphibians, some over 2 meters long, which preyed on fish and smaller creatures near water sources. Even herbivores evolved defensive features. Edaphosaurus, a sail-backed plant eater, likely used its size and sail to deter predators. What sets these predators apart is their evolutionary significance. Dimetrodon and its relatives were not part of the dinosaur lineage. They were precursors to mammals. The adaptations they developed in the Permian, like improved mobility, predation tactics, and even body temperature regulation, were evolutionary experiments that would shape the future of life on Earth. In a world of relentless competition, Dimetrodon and its contemporaries proved that success was about more than size. It was about innovation and resilience. The Permian period wasn't just an era of strange predators and extreme climates. It was also the stage for one of the most pivotal evolutionary milestones: the rise of therapsids, or mammal-like reptiles. These creatures, part of the synapsid group, were distant ancestors of mammals and began to develop traits that would one day define our lineage. Therapsids were innovative survivors, evolving features that gave them an edge in the harsh conditions of Pangea. One of their most significant adaptations was their jaw structure. Unlike their reptilian cousins, therapsids had more complex jaws, which eventually evolved into the mammalian jaw. They also had specialized teeth, including incisors for cutting, canines for tearing, and molars for grinding, allowing them to process a wide range of foods, a critical advantage in unpredictable environments. Therapsids didn't just adapt physically, they may have been among the first animals to regulate their body temperature. Fossil evidence suggests that some therapsids were warm-blooded, which allowed them to stay active in the fluctuating temperatures of Pangea's deserts. This trait, combined with burrowing behaviors in some species, helped them survive the cooler nights and hotter days that made life so challenging. One remarkable therapsid was Dimetrodon, a plant eater with tusks and a beak-like mouth. Fossils of Dimetrodon have been found across several continents, showing how adaptable this genus was to different environments. Another therapsid, Thrinaxodon, may have been one of the first creatures to develop fur, providing insulation in colder climates and protection from the intense sun. The rise of therapsids during the Permian was nothing short of revolutionary. Their evolutionary breakthroughs, specialized teeth, body temperature control, and even fur helped them survive the challenges of the Permian and laid the foundation for the mammals that would inherit the Earth millions of years later. While life on land was transforming, the oceans of the Permian were no less dynamic. The vast global ocean known as Panthalassa, surrounded the supercontinent Pangea and hosted some of the most diverse ecosystems in Earth's history. Coral-like reef builders, sponges, and algae formed expansive underwater habitats that supported an astonishing variety of marine life. These reefs rivaled today's coral ecosystems in their complexity and productivity, providing food and shelter for countless species. However, the oceans of the Permian were highly unstable. Rising global temperatures caused oxygen levels in the water to plummet. This created sprawling hypoxic zones, dead zones, where marine life suffocated. Think of these dead zones like modern pollution hotspots, places where fertilizer runoff or climate change disrupts ocean systems, leaving areas devoid of life. The Permian's dead zones were like that, but on a catastrophic global scale. These oxygen-deprived areas devastated ecosystems, forcing species to migrate or perish. Reef systems collapsed, and many organisms that had thrived for millions of years were wiped out. Among the ocean's survivors, predators like sharks and armored fish ruled the seas. Permian sharks were smaller and more primitive than their modern relatives, but they were still highly effective hunters in shallow waters. Meanwhile, coastal areas were patrolled by creatures like Mesosaurus, one of the earliest marine reptiles. Mesosaurus, with its elongated snout and needle-like teeth, thrived in brackish and oxygen-poor waters, feeding on fish and other small prey. The Permian oceans also saw the rise of ammonites, ancestors of modern squids and octopuses. These coiled, shelled creatures adapted to the changing conditions and became some of the most abundant marine animals of the time. Fossils of ammonites are found worldwide, offering a glimpse into the resilience of life in even the most challenging environments. The oceans of the Permian were a mirror of the planet's volatility, a place where life flourished, adapted, and struggled to survive in the face of ever-changing conditions. But just as life adapted to these challenges, Earth had one final, catastrophic event in store: the volcanic eruptions of the Siberian Traps. These eruptions were so destructive, they reshaped not just the land, but the climate, setting the stage for the Great Dying. As the Permian period approached its dramatic finale, the Earth experienced one of the most devastating volcanic events in its history: the eruptions of the Siberian Traps. Located in what is now Siberia, this massive volcanic region erupted continuously for hundreds of thousands of years, spewing lava across an area larger than modern-day India. Rivers of molten rock blanketed over 5 million square kilometers, reshaping the land in a fiery apocalypse. The eruptions weren't just destructive, they were transformative. Along with the lava, the Siberian Traps released enormous amounts of greenhouse gases, including carbon dioxide and methane, into the atmosphere. This sudden surge of gases triggered a runaway greenhouse effect, causing global temperatures to soar by 5 to 8 degrees, 9 to 14 degrees. The heating didn't stop at the surface. Oceans absorbed much of this heat, disrupting marine ecosystems and turning waters stagnant and hypoxic. The volcanic activity also unleashed sulfur dioxide, which mixed with water vapor to create acid rain. This toxic rainfall poisoned the soil and freshwater systems, killing plants and animals already struggling to adapt to the changing climate. At the same time, vast underground coal beds ignited, burning trillions of tons of organic matter. This added even more carbon dioxide to the atmosphere, amplifying the warming and creating a feedback loop of destruction. The effects of the Siberian Traps were nothing short of apocalyptic. Plants withered, marine ecosystems collapsed, and species that had thrived for millions of years were pushed to the brink of extinction. By the time the eruptions finally ceased, Earth had become a scorched, toxic world, a grim precursor to the largest extinction event in the planet's history. Can you imagine what it would have been like to witness this apocalyptic transformation? A world on fire, suffocating under its own atmosphere? As the volcanic activity of the Siberian traps wreaked havoc on Earth, life faced a challenge even more fundamental than rising temperatures or acid rain: a dramatic drop in oxygen levels. Atmospheric oxygen, which today sits at around 21%, fell to as low as 10% during the late Permian, equivalent to the oxygen levels found at the top of the high-altitude mountains. For many creatures, this thinning air made survival nearly impossible. In the oceans, the impact was devastating. The volcanic release of greenhouse gases warmed the waters and disrupted circulation, preventing oxygen from reaching the deeper layers of the sea. Vast dead zones formed, areas where oxygen was so depleted that most marine organisms suffocated. Coral reefs, which had flourished for millions of years, collapsed, and predators like sharks and armored fish saw their ecosystems crumble. Only smaller, hardier organisms, like certain mollusks and crustaceans, could cling to survival in these hostile waters. On land, oxygen starvation created similar struggles. Large reptiles and mammal-like therapsids, which required significant oxygen to fuel their metabolisms, were particularly vulnerable. Moving, hunting, and even breathing became a struggle. Smaller animals, such as burrowing therapsids like Dimetrodon, fared better. By burrowing into the earth, they could escape the harsh surface conditions and conserve energy, giving them a chance to endure when larger creatures could not. This oxygen crash was directly tied to the chain reaction of volcanic activity and warming. Plants and plankton, the primary producers of oxygen, were dying off due to heat, toxic rain, and disrupted ecosystems. Without them, the oxygen cycle collapsed, further intensifying the crisis. Without these oxygen producers, it was like someone had turned off the planet's life support system. The air grew thinner, suffocating land and sea creatures alike, creating one of the most hostile periods in Earth's history. The Great Oxygen Crash marked one of the most suffocating periods in Earth's history, forcing life to adapt or die and setting the stage for the extinction event to come. Around 252 million years ago, the Permian period ended in devastation with the Great Dying, the most severe mass extinction event in Earth's history. Over 90% of all species disappeared, leaving the planet almost barren. The causes of this unprecedented event were many, but at its core was the catastrophic volcanic activity of the Siberian traps, which triggered a series of interconnected disasters. The volcanic eruptions released massive amounts of greenhouse gases like carbon dioxide and methane, causing global temperatures to rise by as much as 8 degrees, 14 degrees Celsius. This rapid warming was more than most species could handle. In the oceans, warmer waters held less oxygen, creating enormous hypoxic zones where marine life suffocated. Coral reefs, which had thrived for millions of years, collapsed, and predators like sharks and armored fish faced extinction. Even the hardy ammonites, once resilient to change, saw their numbers dwindle. On land, the situation was equally grim. Rising temperatures, acid rain from sulfur dioxide emissions, and the rapid destruction of vegetation left herbivores without food and predators without prey. Forests disappeared, turning fertile areas into lifeless wastelands. The few species that survived were small, adaptable, and capable of enduring extreme conditions. One of the most catastrophic effects of the Siberian traps was the release of methane from melting permafrost and ocean sediments. Methane, a greenhouse gas far more potent than carbon dioxide, created a runaway warming effect that further amplified the destruction. This feedback loop of greenhouse gas emissions and rising temperatures ensured that ecosystems collapsed faster than they could recover. The Great Dying reshaped life on Earth forever, but it also paved the way for new beginnings. The survivors of this mass extinction, small reptiles, burrowing therapsids, and marine pioneers, would rebuild the planet's ecosystems, setting the stage for the age of the dinosaurs. For a deeper dive into Earth's ancient catastrophes and the civilizations that emerged afterward, grab a copy of our ebook Secrets of the Ancient World. It's a fascinating read that connects ancient events like these to the mysteries of our human past. Check out the pinned comment for the link. The Great Dying left Earth devastated. Over 90% of all species had vanished, and ecosystems that had thrived for millions of years were destroyed. Yet, life proved its resilience. The small number of survivors adapted to the drastically changed planet, laying the foundation for the next great chapter in Earth's history. In the oceans, the extinction of dominant species like reef builders and large predators opened up ecological niches for new groups to emerge. Early relatives of modern bony fish began to diversify, and marine reptiles like ichthyosaurs and plesiosaurs would soon rise to dominance as apex predators. These creatures thrived in the oceans of the Triassic period, rebuilding marine ecosystems piece by piece. On land, the survivors were small, adaptable creatures that could endure harsh conditions. Burrowing therapsids, ancestors of mammals, managed to hold on, continuing their slow evolution toward warm-bloodedness and more complex behaviors. However, it was the archosaurs, the ancestors of dinosaurs, crocodiles, and birds that took center stage. These creatures were uniquely suited to the new world, adapting quickly to the hot, dry conditions that followed the Permian. Over time, they diversified, paving the way for the rise of dinosaurs. The recovery from the Great Dying was slow, taking millions of years. Ecosystems gradually stabilized as plants, insects, and animals repopulated the land and seas. During this time, evolutionary experiments flourished, shaping the biodiversity that would define the Triassic period and beyond. The end of the Permian was Earth's darkest hour, but it also marked the beginning of something extraordinary. From the ashes of extinction came the resilience of life, setting the stage for the age of the dinosaurs and eventually the evolution of mammals, including us. If you've been enjoying this deep dive into the Permian period, consider supporting the channel with a super thanks. Your contributions help us keep uncovering the secrets of the past and sharing them with the world. The Permian period was one of the most extraordinary and transformative eras in Earth's history. It was a time of towering deserts, pioneering plants, and evolutionary leaps that brought us closer to the mammals and ecosystems we recognize today. But it was also a world shaped by extremes, scorching heat, plummeting oxygen levels, and the devastating eruptions of the Siberian traps. These forces culminated in the Great Dying, an extinction event so severe that it wiped out over 90% of all life. And yet, the story of the Permian is not just one of destruction, it's also one of resilience. From the ruins of extinction, survivors like therapsids and early archosaurs adapted to the transformed world, paving the way for the age of dinosaurs and eventually the rise of mammals. The Permian period reminds us of life's ability to recover, even in the face of overwhelming odds. And now, as promised, here's the staggering fact about these eruptions that redefined life on Earth. The Siberian Trap's volcanic eruptions burned through trillions of tons of coal, releasing enough greenhouse gases to warm the Earth by up to 8 digs, 14 dig. This runaway warming turned the planet into a near uninhabitable furnace and contributed to the largest extinction event in history. Understanding these ancient events gives us a window into the fragility of our own ecosystems and the importance of protecting them today. Thank you for joining us on this journey into the Permian period. Remember, the story of the Permian period is just one chapter of Earth's rich history. If you're curious to explore more, subscribe to the channel and check out our ebook in the pinned comment. Let us know in the comments which part of the Permian period surprised you the most. And if you're curious about other extinction events or evolutionary mysteries, tell us what you'd like to see next. And until next time, keep questioning, keep exploring, and keep the flame of curiosity burning bright.